Hello and welcome to the segment number 4 of the course, Geographical Peculiarities of Kuttanad, Environmental Issues and Solutions. So, in segment number 1, 2 and 3, we have discussed about the basic geographical and geological features of Kuttanad in brief. What are the effects of flood, the past flood and the recent mega flood in Kuttanad, and also the flash floods as well as the frequent floods in Kuttanad. And then we discussed about some of the flood mitigation measures in the segment number 3 precisely. What are the merits as well as demerits, as well as where it has been successful, where it has been not successful. These things have been discussed in the previous segments. Now, in segment number 4, based on the knowledge acquired in discussing these things, the flood mitigation measures, flood adaptation measures which have been happening in the place, certain case studies are going to be discussed in this particular segment onwards. So, certain projects were conducted starting from Alappuzha city, where the canals were to be rejuvenated. So, in this segment number 4, we are going to see the typical or a particular case study, the case study number 1 precisely, which is named as the Alappuzha Canal Rejuvenation Project. As a preface of this, we can recollect that Alappuzha has been recognized by the UNEP, the United Nations Environmental Programme, as one of the best cities in the world among the 5 cities that have recognized for the best solid waste management practices. So, earlier if you walk through Alappi, maybe in the 2014-2015 that time, you could see people dumping waste on the roadside and the wayside. That kind of a habit has been totally eradicated by the combined effort of the Alappuzha municipality and facilitated by the state as well as central government at that time. So, in 2017, the UNEP has recognized Alappuzha as one among the best solid waste management practicing cities in the world. But what happened after that is people started throwing their waste, though the waste bins were available, segregation, everything is being done. People did not lose their habit. Though the waste bins are available, like aerobic waste to be dumped in one particular say dustbin, anaerobic waste, plastic waste and other dustbins, those things are available. People started throwing their waste into the canals, and sooner or later the canals become dirtier than before. So, that is what triggered the Alappuzha municipality and the then state government of Kerala to have a wastewater management system to Alappi. So, there was a excellent canal system which is existing in Alappi. There has been from the time of the Raja Keshavadasa period, there has been excellent canal system existing in Alappi, and the purpose of the canal system is to transport goods and to drain of the storm water. So, to survey the canals, to see whether the canal is a drain or whether the canal is a transportation canal, etc., we have taken up the project along with IIT Mumbai and the KILA. So, that is what is going to be discussed as an experiment, as a case study in this particular segment. So, the Alappuzha Canal Rejuvenation, we have to call it as rejuvenation because aquatic life was completely dead in the canals. Not even a fish can be seen, not even a tetrapod could be seen inside the canals, because there was absolutely no oxygen inside the canals because of waste dumping, because of dirt and because of many other things. You couldn't even go to the canals without closing your nose. That was the situation. So, canals are envisaged for transportation, as you see in the slide, for people as well as goods. Stormwater drainage, canals should no longer be wastewater drains, wastewater outlets. So, black and grey water outlets. So, what the people of Alappi were doing at that time was they opened their drains from the kitchen, drains from the toilets open to the canals. So, canals got contaminated because of that, and carrying all these waste. The smaller canals went into the larger canals, and they went into to the tributaries, and further they went into the major canals. Finally, the Vadai Canal as well as the Commercial Canal, which were the two major canals of Alappuzha, they were totally contaminated because of this. And the municipality has been taking its effort to clean the major canals only in the past. So, the minor canals are supposed to be cleaned, and a habit has to be maintained over there, so that no longer the canals have to be contaminated. So, small canals and the drains should drain off rainwater quickly to larger canals and further to the big lakes. Canals should no longer create adverse health effects. These are the purpose of the canals for sure. And in the Alappuzha Canal rejuvenation, the objectives are listed out like this briefly: to ensure natural flow of water. First of all, clean the canals, as the municipality does every year, but not enough. Ensure available slope. So, the canals will be having a natural slope for sure, but the slopes would have been prevented. The natural flow of water through that slope would have been prevented due to silting as well as deposition. So, natural slope has to be maintained in the canal bottom. So, the quantity, how much quantity of silt and the debris has to be removed, that is to be taken, the quantity, and how much is to be filled up, that is also to be taken. Then, to ensure aquatic life, convert many of these non-engineered soak pits which were available in the households and septic tanks, and allow only treated water into the canals. So, we have to convert all those non-engineered soak pits and tanks into engineered ones. So, we have to retrofit them either, or we have to reconstruct them, and then let out water to the canals only if it is non-contaminated. That is another objective of this particular program. Aerate canals naturally. So, canals should have life for sure. For that, oxygen should be there, and aquatic life should come back to the canals in terms of the aquatic plants as well as aquatic organisms, other organisms. Then, constructed wetlands is another means by which you can bring back life into the canals. Aquatic plants are another thing. To maintain life in the canals, ensure good health to the public. So, once the canals are maintained, public health also would be improved. So, public awareness programs, canal committees could be formed. So, habit of the people also have to be changed in due course of time. That was the aim at that time and objectives. So, the part of the college in involvement of this canal rejuvenation was to get the quantities first of all. That is the primary thing. So, requirements were to the quantification of desludging, desilting and filling. That was the primary thing. So, slope of the canal from the exit of the canal to the mouth, or the mouth to the exit, it has to be maintained. Canals should increase their width. If the width is not sufficient, we have to increase the width of the canals. Then sidewalls of the canals, you can see in some of the pictures which I am going to show now, you can see many of the canals are abruptly changing their sizes, maybe from a shallow canal to a larger canal, or the vice versa. The sidewalls may not be protected, sidewalls may be protected, but with weaker materials and things like that. Sometimes the canals may be fully closed, you can see such things. Then levels of the canal bottom, they are to be taken. The reduced levels of the canal bottom are to be taken with survey instruments, civil engineering instruments. Level with respect to the sea level, that is a primary thing. Level of the canal side or the canal bunch. Then depth of canal is required. Thickness of the sludge to be removed is also to be required. So, you can see a typical canal is, the photograph is given here in the picture, in which the canal is not does not seem like a canal itself, it is like a drain only, right. So, the width of the canals vary from like 0.5 meters to say 17 meters in Alappuzha. So, these are the methodologies which were adapted to survey the canals to get the quantities from the canals. A total length of 8.1 kilometers of the canal system, the canal network in Alappuzha has been surveyed. and establishment of a benchmark. So, the details of this, I think it is close to civil engineering. I omit some of the say minute details of this as part of this particular course, but still going through the major part of the methodology, we have to establish a benchmark, we have to establish the levels of the canals at the canal side, and then we have to go into the canal and take the levels of the canals at the canal bottom. So, maybe on the when you go into the canal bottom, the depth of the canal at the left end, the middle or the center and the right end were required, and for that access to the canal was a problem. How to get the canal this depth is also a problem, how to get it. Then whether there is a sidewall protection, whether there is a road approach to the canal, these things were like to be observed. So, all these things were surveyed in that particular part of the methodology. So, at each survey station we can see we have to have the staff reading at the bank of the canal, we have to have the width of the canal, we have to measure the depth of the canal, and for that a methodology has been devised. So, the reduced level of the canal side bank has been established from a given benchmark, and at the benchmark at the canal side bank a horizontal scale was established, a long scale was established, so that it is water level, it is perfectly level. And with respect to that scale, vertical distances to the canal bottom were measured using a vertical scale. So, we maintained the horizontal stature of the scale as well as the vertical stature of the other scale. So, on the right end, left end as well as center of the canals, the levels were measured. The vertical scale was inserted into the canal with natural human force, and the depth of sludge will be available as the black mark on the scale, and the depth of water can be measured as the water level, which can be seen from the scale. So, the depth of water and the depth of sludge were measured accordingly. And then after these measurements were made, the compilation of the observations were exercised using first of all using a mobile app. The mobile app was named as ODK Collect. So, the reconnaissance survey was done using this ODK Collect. The features like whether there is sidewall protection, whether there is whether you require kind of say at the bottom say if you require the increase of width of the canal, these things were observed by the ODK Collect. What is the length of the canal, and at which points the canal changes abruptly, whether it changes to say sharply to 90-degree bend or things like that. They were observed through this ODK Collect. And how much vegetation is there in the canals. In the previous two figures you could observe that in some of the canals there were vegetation inside the canal, and in which canals you have a compound wall standing on both sides. So, those things also were observed by this ODK Collect kind of mobile applications. The reduced levels of the canal bank and the canal bottom, left, center and the right are determined. So, that is a natural calculation in the civil engineering say survey scenario. Canal profile, finally, as a result the canal profile, width of the canal versus length, reduced level of the canal bank versus length, reduced level of the center of the canal bottom versus length, they were plotted. And I can show you a typical example that is coming in the coming slides. After doing that, the quantity of waste, sludge and silt to be removed from the canals and how much filling is required, they are calculated. That is part of the compilation of observations and part of methodology for sure. Suggestions on sidewall protection, whether you require sidewall protection, whether you have to modify the existing protection, etc., they could be suggested, and widening of canals if required could also be suggested, and at the same time ensuring flow through canals they are put forward. You can see the job was not that simple. You can say taking measurements is what? It is measuring the width of the canal, depth of the canal and length of the canal. It was not that easy. You can see, as you see in the picture, some of the canals have on both sides, on both the banks of the canals, say compound walls like that. So, the canals were not accessible, and you see so much of debris were thrown into the canals. Width of canal is that canal of maybe of the order of 2 meters or 2.5 meters only. And on the right side, you can see in the next figure, there is an encroachment above the canal. Not only some portion has been covered by a slab, but other portion is encroached by some local people. So this also has to be taken care of during the survey. You see in the next figure, next photograph, we can see that there is an abrupt change of a canal from a larger width on the farther side to a shallow width on the near side. And in the portion where there is a shallow width, you can see there is sidewall protection on both sides, but in the portion where there is a larger width, there is no sidewall protection. And on the right side, as you can see, on both sides there is no protection at all. And if you walk through the banks of the canal, the banks may slide down. That was a kind of soil available there. You see, these are not canals but simply drains. So the drains were covered with slabs. How do you get the depth of sludge, and how do you get the other parameters, dimensions of the canal? That also was a difficult job. You can see on the right side in the second photograph, there is no covering of slab, but the entire drain is filled up with debris, or it is silted fully. Those were challenges. You can see on the left also, what you see is a canal only. You cannot see water there, but it is just like a waste dumping yard. But that was originally it was a canal, so it has to be rejuvenated back to a canal. That was also a challenge. On the right, you can see there is a lot of vegetation which is growing inside a canal, and on the right side of that you can see a compound wall. So this kind of challenges were there, and students actually who were involved in that, they were wise enough to overcome such kind of situations. As you can see, the instrument was kept on a compound wall on the left, and a student is lying down. After leveling the instrument and centering the instrument, he is taking levels, lying down over there. So without a tripod, without standing on the earth, he is doing that improvisation. Now this is a typical example. The canal by name Shadamani Canal. This is a typical curve of width of the canal versus the distance or the length of the canal. You can see the total length of the canal is close to 2.25 meters or so, less than 2.25 kilometers or so, less than 2.5 kilometer. And you can see that the width is varying abruptly from close to say 1.5 meters, it varies up to more than 5.5 meters. So that is the kind of variation available. So originally the canal would have been having a width of 5.5 meters, and that in due course of time, because of encroachments or otherwise, the canal width would have come down. You can see another set of graphs in which the reduced level of the center of the canal is drawn on the y-axis and the figure on the top, versus the length of the canal, the same canal only, Shadamani Canal. And you can see that there is a slope, natural slope of the canal from the left end to the right end. That was there, but in between there are peaks, and those peaks represent siltation. Debris were there, waste was there, other kind of depositions were there, plastic will be there. So those kind of siltations made the canal like that. And if you cut off all those peaks, you can get the figure below. The cutoff of that peaks actually amounts to the volume of sludge to be removed from the canal. So the troughs were not filled up, but the peaks were cut off in the canal. So that is how it was envisaged finally. That was how the report has been given finally. So like this, there were kind of 10 number of canals were there. All of them were surveyed, and such kind of plots were made for all the kind of canals. And a report has been sent to the Irrigation Department of Kerala. Finally, this is a table which is sent to the Irrigation Department. The total volume of sludge to be removed from the canals is, it was a 8.1 kilometer stretch of very shallow kind of canal, so the volume is also very less. The volume to be removed is close to 5,000 cubic meter. But when we surveyed another canal which is extending from Alappuzha to Ambalappuzha, the name of the canal was Kakathodu. So when that canal was surveyed, there also we got near Alappuzha, the width of the canal was like 2 to 3 meters, and when it went up to Ambalappuzha, the width was increasing up to 17 to 18 meters. The total volume of sludge which would be removed from such a canal, it was close to say 2 lakhs or 3 lakhs cubic meter. Another table which is produced as part of the survey analysis and sent to the irrigation department for further action, the requirement of sidewall protection. So, how much meters of the canal sidewall side bank are to be protected and which material is to be used. So, such kind of a suggestion has also been given to the irrigation department, and now they are executing this. So, the associated actions as part of the analysis results and the kind of observations are as follows: removal of vegetation in the canals, if any, that is the primary thing. Then the sidewall protection of canals after raising if required via ferrocement slabs, that is one of the suggestions, because ferrocement slabs are easy to construct, or you can use Kair geotextiles as another method. You can use say granite stone masonry as applicable, as required. Desludging or desilting with suitable machinery or manually. So, for small canals you may have to sometimes do it manually. For larger canals you can use the available machinery, or you have to actually sometimes you can invent a machinery also. That was also part of the project. The sludge shall be pressed to dewater and stored temporarily in the canal bank, at the canal bank, and later they can be transported via suitable vehicle. Then the canal profile shall be corrected in the initial phase. After desludging, the canal profile will be corrected, but later it has to be checked through a secondary survey. So, once water is flowing in the canals, then the profile has to be corrected again and again. But that is not enough. In fact, you have to change the habit of the people. That is something to be discussed towards the end of this particular segment. The base of the canals shall be prepared to facilitate flow and not to disturb the foundations of the neighboring buildings. Very important thing. So, we observed that many of the buildings which are close to the canals have their foundations close to the canal boundary. So, when the desludging is done in the canals, such kind of foundations should not be affected. So, we have to take sufficient care in doing so. Then decentralized sewage treatment in the nearby buildings. All the buildings which are very close to the canals are actually pumping their sludge as well as grey and black water into the canal. So, that has to be stopped. The waste has to be treated at their premises itself. So, decentralized sewage treatment plants should be established in every building, and if not possible for clusters, for example, if somebody is living together say in clusters, then a cluster sewage treatment plant can be established over there. That is also established in the place. Then introduction of filters at desired length of the canal, designed length of the canal, and at desired distances along the length of the canals, and canal committees were entrusted to say training of students also were done, and canal committees were entrusted to take care of that portion of the canal. So, each segment of the canal is given to a particular canal committee that is guided by, or that is governed by the ward member of that particular place. So, they can take care of whatever debris is further being thrown into the canals, they can take care of that. That was the idea. Then conducting awareness programs, that is very much important. So, this process is initiated and that is now going on in the Alappuzha city, but not sufficient. We have to check whether the quality of water is sufficient enough for the aquatic plants to grow and the aquatic organisms to grow over there. So, to bring back aquatic life, this is required. The BOD, the biochemical oxygen demand of the particular water has to be brought down to a level of less than 30 milligram per liter. So, that is the kind of BOD with which aquatic plants can live to an extent. Constructed wetlands also can be used when the canals are bigger. We can have floating wetlands over there. So, this is the subject of this particular segment. That is the first kind of case study which we have done in Alappuzha, and later with the knowledge gained through this Alappuzha canal project, we went into the other case studies in Kuttanad, other projects in Kuttanad. Thank you.